Alright, now solving for quadratic equations. You could call a quadratic equation a second degree polynomial. Now, if you need a refresher on what polynomial means, you know poly means multiple. Oops, I don't want to do that. Multiple. And nomial is like, well, that's a word, the root word for name. Or that is, it's got multiple different kinds of expressions for x. You know, binomial would be bx plus c equals 0. Anything over a binomial would just be a polynomial. So you've got bx plus c equals 0. It's a binomial. So anything with x squared, so it's like a secondary degree or second order, plus the first order, plus something else equals 0. We'd call that a polynomial equation or a quadratic equation. So what we want to do is whenever we see something that is squared, that is x squared, plus the first order version of it, plus x, plus whatever else, we want to put it into this form. Ax squared plus bx plus c equals 0. That should look familiar to you because you have a couple different equations at your disposal to solve for that. Now, if the b is 0, for example, if this is 0 right there, and that makes that whole middle thing go away, then that means you would have an equation that would essentially look like this. Ax squared plus c equals 0. Okay? And if that's the case, then you could possibly use the square root. Let's erase this. I should say square root right there. Square root, there we go, method. Okay, where in which case you would have two brackets right here, and you would be like something x, something s plus something times something x minus something. Remember that? You could possibly use that. If not, if b equals, or if b is not 0, equals something other than 0, well, then you have to do a little bit more work. You could use some graphical techniques, which we'll look at, but also you could use, this will come in very handy, the quadratic formula. Okay, and that's a big, long b equals square root of plus or minus ax squared. I can't even remember off the top of my head, but we do have it at our disposal. We also have the quadratic formula in calculator form as well. So you could possibly take that and punch it into your calculator, and I'll give you some tools to do that as well. Part of the reason you did it in math class was to show that you could do it, that long equation, but we have an automatic version that I can give to you and show to you. So anyway, that's solving for whatever x is. And it may give you one or even two different answers for that, but that's what a quadratic equation is right here. Okay, so let's look at some other kinds of equations here that we can undo to solve for a variable that we don't know. Let's say in this first one right here we want to solve for f, that is the lowercase f right there, and get everything else away from it. Well, we've got all this mess right here multiplied to it, so what do we do to undo the multiplication? We divide, right? So let's take all, that's supposed to be another parenthesis right there. We take all this stuff and divide that. So that'll come across the equal sign and down below the FC. So the f sub c divided by 4 pi squared times m times r equals lowercase f squared. We can't do anything with the f squared quite just yet, but now we can because it's all by itself. So we want to undo this squared right here. So it means we're going to have to square root both sides, right? So take the square root of the right-hand side, we'll just come up with f, which is what we want. But then that means we've got to take the square root of the whole left-hand side. So that whole thing right there, f sub c. And it might help to put this in a parentheses right here. That means you know everything is going to be square rooted. 4 pi squared times m times r. All that goes in that bracket, and all that gets square rooted right there. And that is our answer, solving for f. How about the one on the right-hand side? All right, now if we're solving for vi right here. Okay, this is kind of messy. It's locked in this square. The square right here, it's also being added, or actually, in this case, subtracted with 2g delta y. So let's get rid of that addition and subtraction first. So it's being subtracted on the right-hand side, so let's add it, 2g delta y, and that means it has to happen over here too, plus 2g delta y. So v squared plus 2g delta y is going to be equal to vi squared. All right, and once again, now we've got this value that we want to know, but it's squared, so how do we do that? We undo it with the square root. So square root this side, just like that. It means that 2 goes away, the square goes away right there, and that means we need to square root that side. So ultimately, square root of that should be vf, shouldn't it? Vf squared plus 2g delta y, and remember that all goes, you can put that into parentheses so you know it all gets squared, equals v sub I, just like that. Much nicer and neater than it was previously. All right, so what if you have an unknown that is that says greater than one term, all right, or that is more than one term? All right, so the unknown you're solving for, if you got more than one term, first of all, you'll do some addition and subtraction first to get all your unknowns to one side. Okay, and then get everything else away from it. For example, let's just do something like this: 3x equals 2x. Doggone it. My stylus is not working very well today. Plus 1. All right. Well, if you want to solve for x, you want to get this 2x and 3x over there together. All right. And then get everything else away from it. Factor out your unknown. So that means your x would come out front of your 2 and 3. And then everything else you would divide or multiply to the other side. Now, I realize I would just kind of talk through that real quick. Let's see if we can look at an example or two that hopefully make a little bit more sense. All right, so right here we're looking at, we're solving for the capital F right here. Wow, this is really messy because we've got this 1/2 f out here. We've got this mu, which is a multiplier, and then this subtraction in here, and this 1/3 f. It's like, holy cow, what do we do? All right. Well, we want to unlock this parentheses right here. So the only way to do that is to distribute this mu to both expressions inside of it. All right. So that means it's going to be 1/2 f equals mu mg minus mu 1/3 f. Actually, you might want to put the 1/3 out front. 1/3 mu f. It doesn't really matter because it's all being multiplied together. Okay? All right, so we did that. So we opened up this, we unlocked this parentheses right here. Now let's start getting the f's together. All right? So I'm going to write down here, move all f's together. Okay, so we want to move this f over to this side and get it with the other f right there. All right, so let's go ahead and do that. So this whole expression is being subtracted, so I want to add it to both sides, which means it'll come across the equal sign and be added. So that means 1/2 f plus, I'll put the 1/3 out front now, 1/3 mu f, capital F, is going to be equal to mu mg, just like that. All right. Now what's kind of nice is now we have the f's over here all not by themselves but all together. So again, we're working on getting the f's by themselves. So what do we do? Let's factor out the f's. All right, I'm going to turn my thing sideways here for a minute. Factor out the f, so we get the f's all by itself. So the f is going to, capital F is going to come out front, f, and then put in parentheses. So what's left is the 1/2 plus the 1/3 mu equals mu mg. That is just ugly. Sorry guys, I didn't plan that out very well. Let me just leave a little more space right here. Let's try it again. So remember the f comes out front, so 1/2 plus 1/3 mu. Remember the f came out front because it was factored out, equals mu mg. Awesome. Great. So the f is kind of by itself, but it's still being multiplied by this whole mess right here. So what do we do with that? Well, let's unmultiply it. Let's divide now, right? D-I-V-I-D-E. Divide all this stuff right here, and it will come across the equal sign and down below. So that means our f is going to be equal to mu mg in the numerator divided by 1/2 plus 1/3 mu. It's not super pretty, but that's the equation that defines exactly what f is right there. So we've done it. We've gone and unlocked this f from being buried way inside this this parentheses and multiplied and subtracted and all that stuff to being all by itself simply by undoing operations. All right. So what if though you have an unknown that's in more than one term? Now, sorry for the way this looks right here. This should be in standard quadratic form. And this should say ax squared plus bx plus c equals 0. And if x is what you're solving for, if you're solving for this, well, this x squared and this bx right here, and that means that a and b and c are coefficients that sit out front. All right, so the x squared is going to be, that is, your a is going to be joined to that. Your regular old first order x is going to be your b, and any other variable is going to be c. I'm going to set it equal to 0. If you're using the quad form equation, which I alluded to before, this is a calculator program that I will give you where all you have to do is punch in what a is, what b is, and what c is, and it will give you what x is. Sometimes you'll get two answers. Sometimes one of the answers is clearly wrong. Other times you'll have to figure out which of the two answers is right. But this is a heck of a lot easier than doing the quadratic equation out longhand. The b equals plus or minus the square root of 4ac over 2, all that stuff. We know you can do that, all right? This quad form, or this quadratic equation calculator, will do the trick for you, and it'll save you some time and hopefully some headache as well. All right, so let's solve for t right here. Let's solve for t when x, that is, or delta x, equals 20, when our vi equals 5, and our a equals 2. All right, and I'll show you how to do that. Well, first of all, let's put this in general form. All right, we're solving for t, and so that's our unknown. So our squared is going to be here, so let's put that in the right order. If ax squared plus bx plus c equals 0, then that means the 1/2 a t squared has to go first. All right, then our first order t, that is multiplied simply by vi, comes next because that's the b. So that's going to be vi times t. And then we want everything equal to 0, so that means that delta x has to come over to this side, so it means it has to be subtracted over. So we're going to say plus negative delta x equals 0. All right, or you could say minus delta x, but I just want to keep it simple for you for right now. So here's your a, here's your b, and here is your c. It's negative delta x. All right? So our a equals 1/2 lowercase a. All right, don't get them mixed up. Our b is simply v sub I, and our c is going to be equal to negative delta x, just like that. All right? So let's punch our givens in right here. All right? If a equals 1/2 lowercase a, well, if lowercase a is 20, I think you can do that in your heads. That means a, 1/2 of, I'm sorry, not 20, 2. I was looking up here. If a is 2, and capital A is 1/2 of lowercase a, or 2, then that's simply going to be equal to 1, right? So, write that right there. Our b, all right, it's going to be vi. Well, when that's already told to us, that's 5. And our c is going to be negative delta x. If delta x equals 20 right here, then that means that c has to be negative 20, just like that. So if I give you the quad form equation, there's also some apps that will do that as well, where you can just key in what a and b and c are. Key in 1 for a, 5 for b, and negative 20 for c. That means you're going to be in good shape, and it'll solve for any possible answers for what t is. Sometimes there could actually be 2 correct answers for t, but we'll look more closely at that a little bit later and figure out how to identify which of those is the right t and which of those is the one to throw out. That's how you do quadratic equations using the quad form equation, and you're going to love this. You're going to love this program when we do it.